So today I have Ananth with me, and we have been waiting since a long time, since last year, to do this conversational style podcast. But due to some personal commitments and some travel plans, it was not possible. So I'm really excited that it is possible today. So I have Ananth with me. So Ananth, can you please introduce yourself for our audience?
Sure. Thanks, Kaivalya. So I'm Ananth. I'm an engineering lead at Humano. So our company is basically building some health and well-being features and capabilities for our end users. I'm an engineering lead here at Humano. I'm leading a couple of teams. One is focusing on building some features, and the other squad is focusing on building some platform capabilities. So building the infrastructure or building some reusable platforms components for other feature squads. But I'm quite happy here. Happy to be here at your podcast today. And yeah, as you said, it's been quite some time. We are planning for this. So finally, it's happening. About myself, also I've been working in software industry for the past 9 years. So primarily, I have worked as a backend engineer, but also have experience working with some full stack development, working on some front end and the backend technologies. Recently, I'm more interested in building my specialization on distributed systems, building microservices. So more on that side. I think that's briefly about myself. As I said, I'm quite excited today to be here and talk about microservices and the nitty-gritties and my experience with that.
Yeah, sounds good. Thanks for the introduction. Sounds very interesting to me. So just to start our conversation, let me ask you a organizational kind of question. How do you think team structure, how teams are organized in a company, impacts the software delivery speed? How does it impact? Is it even related, or it's not?
Yeah, I think it's a very interesting question. It definitely impacts, but also depends on the nature of the company. Are they scaling up, or already are they a big corporate company, right? So it completely depends on the landscape of where that company is currently. Also the kind of projects that they're building, the kind of software that they're delivering on a timely basis. Also we have seen a lot of changes throughout the way how the software is being developed. Before a decade, it was more of a waterfall method, and then we have that regular procedures, and it at least takes a month to deliver something to production. But now what matters the most is the velocity, right? How soon you can deliver some feature, how soon the user can start experiencing that you're building for quite some time. So we have seen all these agile scrum based models, Kanban, all different changes happen in terms of the delivery speed, or even talk about the team structure, the team topology. A lot have changed, but again, it depends on the kind of company, right? The nature of product that you're building. Coming from there, but even though, let's say, even if you're a big company, big organization, even they have their teams working as a small startup, right? It's not something a heavy operation or process involved. Even though you are part of let's say a 10,000 member company spread across the world, still you as a team, you have to operate as a separate startup, right? Your team or your domain, what you're working with. So that's where the modernization happened in terms of how the software team is being operating now. Also the kind of delivery they're doing, but also talking about. So I think the organization structure and the technology engineering side goes hand in hand, right? If they're totally different, then I think there's something that basically you are doing wrong, right? If the organization has a different methodology or different mindset, and then the engineering team is working in a different way, I think there's a big gap there, right?
Yeah.
And also coming from there, it also relates to the Conway's law, right? So then goes to that definition of what is Conway's law, and then they talk about the relationship between the software architecture and the organization, right? Also there's this inverse Conway's law. All this definition, I think it's more of a some guidelines, right? How we can do it, but rather it's also important for your team and the kind of projects that you're building. So you really have to understand what should be the velocity of the project that you're delivering. I think it also the awareness, right? Where where the team wants to go, right? In next few months, they want to release a big feature, or let's say they want to release an MVP or any other different sort of things. I think that's how, like, I mean, in my experience, like I've seen the organization structure and also the speed and velocity of the teams.
Yeah. Sounds good. I mean,
So,
you touched like some of the very interesting points, like the engineering team and the organization itself, like who manages the leadership team. They should have like some alignment into how they want to develop software. So I totally agree on that.
yeah, exactly. Also, a question back to you, right? So, talking about it, also there's a lot of correlation between this definition of the software architecture. Like, I think it has evolved quite a lot. Like before a decade, it was, we define an architecture in a different way, right? But now we are using some terms like monolith, distributed systems, like a lot of different terms are revolving around. I think it's very important to define like what these terms are, right? Like maybe can you give some insight into like what is monolith, and then your experience working with some monoliths?
Yeah, sure. So, I mean, by definition, like monolith only means that you're deploying your software as a one single unit. So it's really about the deployment unit. And so far, what I've seen is like most of the people talk when they talk about monolith, they think it's really bad. Like it's something bad. It's a curse word in software engineering. But I don't think monoliths are necessarily bad. And why, like on the other hand, microservices are necessarily good. It depends on the implementation. It depends on your use case and what works best for you. So if microservices have worked for some organizations, like big organization, that doesn't mean they'll work for you. So coming back to monolith, they're not necessarily bad. It depends on how it is structured. So to give you an example, so if a monolith application, even if you have one big application that is a single deployment unit, it may not be necessarily bad in terms of if you have clear modular structure, if you have loose coupling between each of those modules, as they say, loose coupling and high cohesion. So it makes a lot of difference, right? So the boundaries, how you define, how you communicate between these modules, if it is clear boundaries, it is not like really dependent. So chances of breaking something is really slim. And if you have clear boundaries, if you have like clear picture of like what a component means and what are the boundaries, like bounding context, it is really easy to develop features. It is like easy to develop feature and not break something, like working on order management and then breaking the customer management, because it doesn't make sense. That's not what you want. So I would say monoliths are not necessarily bad. And so give an example, in one of my previous companies, since we were just starting off, it was like it was a big company, but a mini startup within a big company. So we wanted to test things quickly, and we were like a small team. We only had 3 or 4 engineers. So we did not spend a lot of time into designing our microservices architecture right from the beginning. But what we did was we had a monolith application, and we modularized it pretty nicely. We defined the abstractions and interfaces such that they are not broken, and there's loose coupling, and that worked pretty nicely. And then when the product was kind of successful, it was launched to the customers. It was easy for us because the boundaries were already defined, and just to extend that monolith or sort of a single deployment unit and creating or taking one piece at a time outside of that, it was pretty easy. It was pretty straightforward. When I say easy, it was not easy because it was like a production deployment, but it was still not painful as it is with bad monoliths or like heavily coupled monoliths. So what are your thoughts on that?
I think you touched a very important point, right? You mentioned that not all microservices are good. At the same time, like not all monoliths are bad. I think this also leads to a different thought for me. Like I always think like the bad and good coexist, right? It's not something they're separate and then like the whole system, let's say the whole new technology is completely good and then the vice versa. It's not really true.
Yeah.
But also like in my experience, I also had some real bad experience with some monoliths. So I think with what you said, if you don't really have that thought in mind of decoupling the data models, the entities, or even the business flows, so then you might end up building a super tight coupling big monolith, right? So that's where the things start to get wrong. So on that note, like we are building a banking system, and you can imagine how messy it could easily become, right? Like if you really don't separate the business flows there, because like with banking system, it's very critical because they have to be highly consistent and available at the same time. So we cannot really have some trade-off there, right? In building the big banking system, but still, like we really have to understand the bits and pieces, or the separate parts, and then we can define some characteristic for them. But then, like we really missed on that. So when we are building that product, so we are building them as a whole monolith, right? Just a single component, and then they have a lot of interconnections, dependencies with each other, right? And also, like as you're mentioning about deployable unit, we also deployed as a single unit. So which means that if something fails at some point, it's gonna bring the whole system down, which means the user cannot really use any parts of the system, right? But as you said, still from a screen perspective, they are different screens, right? The user might still want different features to be used, right? For example, if they cannot really do a transaction, they should still be able to see the history of what they have done, or even the balance in their account, right? But if you don't allow that to happen, if the user cannot see his or her current balance, also he cannot do a transaction. I mean, in general, the whole system is down. Then there is no point of operating or even having that application in live, right? So that's where we had this different examples. For example, like we have this payment initiation, also payment overview, or different modules. And basically we're building a banking system for a corporate, so we call it as a corporate banking because our clients are corporate clients, and so they do transactions between their corporate accounts, right? It's basically not end to end, like not for retail users, but rather for corporate customers, and then they can do some transactions. So initially it had like it's just like 0 or 100, right? Either completely up or completely down. So they cannot really use the whole system, or even parts of the system for some reason. And like, but what they wanted is they want at least the payment initiation to be successful, right? So then with the payment overview and payment settlement, so they are different business units. And also talking about stakeholders, so they are literally screaming, right? So for example, let's say there's the business people and product people on the payment initiation side. So they were like, kind of, it becomes an environment where we keep on scolding each other, like, and also the team becomes so big, right? So like each other's changes, like blocking others, right? So for example, let's say single deployable unit, single code base, and you cannot, like, there are some conflicting changes, and you need a lot more time to even take that to a production environment. There are also some changes in terms of the delivery aspect, right? So we cannot really deliver them on like as a lean development. So we also had to follow some waterfall methodology there because of a lot of tight coupling, a lot of stakeholders involved, and even like there are a lot of handshakes and sync ups between teams members. But it's very, I mean, at some point it became non-manageable, right? It becomes super big that we cannot really understand like what other teams are doing. I mean, even sometimes like product would come and ask a question, how and why we are depending on this aspect, right? Business wise, they are totally different, but from technically speaking, why are you saying that this is dependent on each other? I think that's where we kind of led into. I think it was around 2015, and then like microservices are getting some fame, right? Like a lot of companies, industries are moving into that,
cool kid.
That's where we, and that's where we started thinking about it, and then we move into this path of having some microservices, and then working from there.
Yeah, sounds good. I mean, you touched upon a few important points, like, you know, like graceful degradation. Like if one thing goes down, it's not like entire system is going down, and you know, our customers are just not able to use any feature of our product. And then you also talked about, how it gets bad when you have a very tight coupled architecture. People are not able to make changes quickly, and they are dependent on each other, and then they start screaming or whatever. I don't know. So I truly believe that managing people is more difficult than managing systems. So
yeah,
I
and
agree
also a
on
lot
that.
of people involved here in building the whole systems. Cool.
Yeah.
Also a question back to you, like that, how do you define microservices, right? So we have
Yeah.
talked quite about monoliths. Also, you talked about good monoliths. But coming from my example, like with bad monoliths, at some point we really have to bring in this microservices, the beast, into the picture. So
Yeah.
how do you define microservices, and what are their pros and cons, right?
Yeah, I think microservices are just, a way of architecting your software into like smaller pieces that are, loosely coupled. They can be deployed independently. They can be scaled independently as required, and you can choose your tech stack differently. So these are just, like a big program, a big product, cut into different pieces that are interacting with each other, but they are loosely coupled. And that's where it gets kind of challenging, right? So, and once you distribute things, there is network in place, there is communication in place, and that's when it gets really interesting. So many failure points are added. So yeah, microservices is just the way you break your big product into smaller components that talk to each other. And how you define these smaller components is the tricky part. Like you define the bounded context, and they should have only one responsibility, and they should not be changed too often. Like for example, if you're changing something on payment processing, it should not necessarily change something on, I don't know, search, or let's say customer management, right? So that is what loose coupling and dividing your system into smaller pieces comes into picture. And yeah, I mean, microservices comes, like, it adds a word micro in it, which talks a little bit about size, but it's really hard to judge, like, what is the true size of a microservices? How can we measure a size of a microservices, right? Like, can it be lines of code? I don't think so. Can it be number of classes? Maybe not. Can it be like the size of the deployable? I don't know. So it's just about the bounded context, the domain that you're talking about, and how is it really independent. So when you make some change, is it the one independent unit that can be deployed or thought about in an independent manner without having a tight coupling? So yeah, that's where it comes into picture.
Yep, definitely. I think
Yeah.
very important point you touched upon, right? The definition of it itself is very important, because sometimes it's misunderstood, especially the size of it. Sometimes people talks about size when they talk
Yeah.
about microservices, but actually it's not really the size there, right? And also, like, quantifying a microservice is not the best approach, right? Like, but there are other good metrics, like, I mean, we can go into that detail later. But also, like, I also have some experience with having some challenges, right? Like, especially, why do we need microservice? We have to be really clear on that aspect. So, and basically, we needed it for two main purposes. Like, one is for the speed, right? The one which we are talking about,
Yeah.
and also the fault isolation, or even more independent life cycle, right? Like, different product features, different business domains, they want different life cycles. I mean, also the autonomy there, right? Like, they are quite autonomous, and then each service can define on their own, as you said, the architecture, the code programming language, right?
Yeah.
It's completely independent. I think that's where, as I was giving this example, the payment initiation, payment overview, like, for some of those services are read heavy services. So we are mainly focusing on making that service that serves a lot of read traffic, but whereas the other services are different, right? So the nature of each services differs. So based on that, we also able to use the right components, right tools, right? So which we don't really have to build for other services. So that's something, but that's also a challenge, right? Like, as you mentioned, even if we build different microservices, then we also might end up in a distributed monolith, like people call it. So
Yeah.
where again the whole purpose is beaten, right? Again, if let's say we build different microservices, but again, like we are again making it interdependent, right? We cannot again have that fault isolation there. The purpose of why we did it. So it happened. Like it also happened for us. Like after we split them into microservices, still we had some one-to-one communication,
Yeah.
a lot of dependencies. Like also there's also like some contract defined between services. Again, like if something that changes on one service, you have to make sure it's compatible with other, let's say,
Yeah.
downstream services. So also those are some challenges. Like, but from your experience, like, can you give some examples? Like after you go into microservice, what are your challenges and how did you overcome that?
Yeah, there are lots and lots of challenges, and I totally agree on whatever you said. Like, I think it really depends on what problem you're trying to solve. So having a microservices architecture just for the sake of having it, like because it's the cool thing to have, no one really works on monolith nowadays. I don't think that's the right approach. So I call it like FOMO driven microservices development. So you just fear on missing out something. But that's not the right approach. I think we should start with the problem. Like, what is the problem that you're trying to solve? Like, even if you have, let's say, a monolith architecture, like, is it really working for you or it is not working? What are the components or what are the things that are not working for you? Are you looking for like an independent scalability, or you're looking for more autonomous teams, right? If you're looking for more autonomous teams, is your organization built in that manner so it can actually support autonomous teams? Do you have enough toolings for that? Like when you split like systems apart, right? They're talking on network. Like it's from the customer's point of view, it doesn't matter. It's still one product, but you have like hundreds of services, right? And then tracking and logging and monitoring and metrics and all these things come into picture. And then unless you follow like a very disciplined pattern of having like correct logging in place, distributed tracing, having breakers, like so that if one system is going down, it is not impacting other systems. So reducing the blast radius, isolating failures, and then also a lot of testing effort. So once you deploy something, because if you want to have like a good microservices architecture, if your motivation is fast delivery, you need to have like CI/CD. And then once you have CI/CD, you need to also have all the toolings in place, because otherwise it doesn't make sense. You're just breaking the customer behavior. If you don't have like automation testing, you don't have monitoring in place, you're not doing performance testing and chaos testing. What happens if one part of your system goes down? How does it impact all other, like the bigger part of your product? And all these things are very challenging. And unless there is a very like kind of strong engineering culture where each engineer has this ownership, like I own this part of the system, but I am also responsible for the entire product, in a way that I cannot make some changes without following some patterns that are followed by others. And then it's also about communication. And you also said about distributed monoliths. So it's an interesting thing. So we start off with having microservices architecture with a idea in mind that we want to autonomously deploy things, but then we create some kind of dependencies that if software A or the component A is deployed, B also needs to deploy it. And then there is ordering of systems, like can A go first or B go first? And then when there is a lot of communication, there are communication gaps, and people are not good in communication. So I think those are all the challenges. So we should really think what we are trying to solve here, right? And not just follow because it worked for, let's say, Facebook, let's say Google. These are big companies. They have different types of problem, right? And I've also talked to some of the engineers where they say we want to scale them separately. But do you really need that? Like, why do you want to scale separately if there is no need, if you don't have that much scale, right? It maybe it just works for you. So I think there are hundreds and hundreds of challenges with microservices if not done correctly. So I agree to you on that.
Yeah, I think you nailed it. Also, you touched upon a lot of aspects. which itself needs a dedicated session, right? Like,
Yeah.
for example, let's say the inter-service communication, how to make it better, right? Or
Yeah.
even which one to choose with, like, should it be event driven or should it be like one-to-one service communication? A lot of, I mean, even with monitoring that you touched, I think it's very important also to provide the tooling and capabilities. Like, even let's say if something goes wrong in one of the service and that gets cascaded over like the whole chain. So we
Yeah.
really have to know from where exactly this issue started and where's the root cause and who has to jump in, right? Which team have to jump in and which service needs that fix. All of this needs a dedicated session to go in deeper into that. But just like, can we talk about some metrics involved in this distributed architecture? Let's say there's SLOs, SLAs, SLIs, a lot of these
Yeah.
aspects. Like, how do you see it? How did you define in your experience?
Yeah. I think this is another very important aspect because ultimately what we are building, whatever it is, like microservices, macro services, monolith, distributed monolith, it doesn't matter. Ultimately, we are solving a problem for the customer, right? And it depends on what kind of experience you're trying to provide. And then for meeting that experience, right, you need to have some objectives like this is what I want. And then you need to be clear on those objectives. And then how do you measure those objectives, right? So, for example, like the search latency could be an objective. Like you want to, fulfill all the search requests, like not all the search requests, but let's say 99 percentile of the search request within 100 milliseconds. So that is an objective. And if that breaks somewhere, you are impacting the customer, right? So you need to start from, measuring things that really matter, but start from the customer and not the other way around, right? You can have hundreds of indicators in your system, but not all of those are important. And then getting these objectives right is also very important. So I have seen in one of the previous companies where they have a strong SRE culture and they were really learning a lot, from real production experience. And what they had was, SLOs on each service. So, like if they have hundreds of services, there are hundreds of SLOs. But then for someone like a product manager or like an engineering manager who needs to, understand like a bigger picture, how all these systems, individual SLAs or SLOs, translate into one SLO, right? So how does it impact the customer? That was like connecting all those dots and creating one SLO was really challenging. So they learned from it and they tried to move away from that. And they used to have like an operations based SLO where instead of monitoring SLOs on each individual service, which gets really granular, they made it a little high level, which was at operations. So whatever operation a customer is performing on a website or with your service. So for example, if you talk about e-commerce, what happens when a customer searches for a product or adds a product to the cart? So what is the latency and other objectives that you might have? So for each operations driven by the customer, you have an SLO, right? And then based on that, how do you measure that? And then you have to, trace it out, what is the bottleneck and things like that. So that is when I think it gets really interesting, and getting it right is really difficult. It needs a lot of experience, for each use case, it can be different. So in my experience, defining SLOs are really important because ultimately that's how you measure how your customer experience looks like, and then getting it right is difficult at the same time. So it needs a lot of testing and getting feedback and improving day by day.
Yeah, exactly. I think a lot of variables involved here, right? Like if one aspect goes up, the other aspect pulls it down. So it's like the real life there. But also like taking what you mentioned is very important. Having an SLO based on the operations, like based on, I think what we also trying to convey here is the user-centric approach, right? Like whatever that you end up like building some new systems or even re-architecting the current systems, with microservices or even with new technologies like event-driven architecture. So whatever the option that you choose, you have to keep your users at the center right? So at the end of the day, you're serving users, right? So you really have to understand what metrics the user really wants, right? Like, for example, especially with availability and consistency, they tend to conflict with each other, right? So
Yeah.
so then you have to have systems which is highly available at some point. But I think availability is very important, right? Like with whatever that the feature that you're like the user is using. So I mean, the user have to make use of a system at any point. And even if you think from an user focused thought, user may not use your app more than 30 seconds, for example, let's say, right? So they come in and then they open it, they do something, they go out, right? Especially with banking systems, they come in 30 seconds, they want to do a transaction, go out of the app.
Yeah.
And then like they do this when they go in a bus, they go in a train, they just walk on a road, right? It's not something they have like 1 hour. Okay, the system is down now. Okay, let's keep on waiting. The screen is loading.
Yeah.
That's not the real user experience, right? That's not what the user wants. So availability is the most prominent aspect, right? But there are some systems which still is running as a jobs, right? The background jobs, or even there are some, I don't know, some background operations that's happening. So that's where you can also compromise on consistency, and then right, you can make sure the system is eventually consistent, right? Even if it's not consistent instantaneously, you can make sure that down the line it's consistent there, right? But consistency also applies for some parts of the system. For example, transactions, right? How can we make sure it's highly consistent, right, with banking transactions? So yeah, I mean, at the end of the day, it's always the user, right? With whatever that you do, it doesn't matter, like, is it the microservice that you're using or not? But if you try to find a way, any way, where you make your users happy, and also the ever increasing load on your system, right? Because like it's not the same user after a year. Like, there could be a number of users, so you really have to predict what's going to happen in next few months and years, right? So that's why like you're also building things for future, right? It's just not for sometimes not for today and not for tomorrow, but it's for next few months and next for a year. You don't really want to re-architect again, right? Like it's also something that, yeah. So again, user being that centerpiece.
Yeah. I totally agree. I mean, as you said, you covered a very interesting point. Like you don't want to re-architect things pretty often, right? So at least it should not be a major re-architecture. So, and that's when all these best practices and, a lot of testing and what works for you in your use case, keeping the user in mind, it really helps. And you also touched upon, availability and consistency. And that is already like a big topic that people talk about, in distributed systems. Like, what can you choose? You have to choose one. You cannot have both because there is network partition and things like that. So as you said, like depending on the use case and depending on how your consumer or the customer is like consuming your service, it depends what is higher priority for you. Is it availability? Is it consistency? And then it's not even like for one product, there can be parts of it where people might want availability as compared to consistency. Like people want your search to be always available, right? Search going down is a terrible experience for the customer. On the other hand, like some other small feature, like some banner is not showing up, or it's showing, but it's not consistent. It's showing some incorrect information. Maybe that is not a big deal. So even in one product, there are like small components which are backed up by, again, different systems. They have different guarantees. So starting with the customer and, thinking right from what the customer experience is going to look like is really important. So I think we touched upon like a lot of different, important points, and a lot of them might require, different conversation for, in-depth understanding. And so just to, briefly summarize what we have been talking about, I think you covered interesting points about, how organizations can be structured to actually support that like new architecture, or how we call microservices, or even monolith, right? And then we also covered like monoliths are not always bad. It depends on how you structure them and how it grows with the organization. On the other hand, you mentioned microservices are not always good, right? It's not like the default standard, like the gold standard of software architecture. It's not like that. It depends on the use case and how autonomously you can deliver software? Is it really solving the problem for you, or it's just like some fancy architecture that you have? So that is another interesting point. And then in microservices, we talked about challenges, like what kind of challenges or pain points of having a microservices architecture is. So that is really interesting. Did I miss something, or you want to add something on the conclusion?
No, I think even we covered a lot, right, than what we expected to cover.
Yeah.
So also we touched upon a lot of follow-up SQL discussions, right? Like we might get into, we might need a dedicated session just for how do you manage availability and consistency? How do you balance that? How do you choose the right technology or the architecture patterns for some of the communication patterns between services? I think we really need more time to discuss about it. But I think for today, I think I really enjoyed the conversation, right? Also, with all your insights, I've learned. I also like it's going to be useful for the audience too.
Yeah, I totally agree with you. And thanks for giving time for my podcast, and having a discussion on such a kind of hot topic. I actually learned a lot of insights from you, and I'm pretty sure our audience will also get some insights into what they are doing, and from more practical standpoint and not just theoretical, like bookish language. So thank you so much, and we should definitely schedule like another session for discussions on all the action points or all the things that we did not go in deep into. And looking forward to it. Thanks a lot.
Cool. Thanks you too.